One question that often comes up in project evaluation is whether you should use one discount rate for every year's cash flow. For example, the firm's cost of capital might be 12%, but the project goes over 10 years. Should you use 12% for every one of the years of the life of the project? And it turns out that the answer is not necessarily. There's a special condition whereby you might want to use the same discount rate for every year. That special condition is when the term structure of interest rates is flat. The term structure of interest rates are the interest rates at different maturities, and usually it's quoted in terms of government bond interest rates. So the term structure is upward sloping when the short-term interest rates have a lower yield to maturity than the longer-term bonds. And the term structure is flat when interest rates of all maturities, whether it's 90 days or 30 years, are identical. The term structure is downward sloping, or so-called inverted, when short-term interest rates are higher than long-term interest rates. Now it turns out that the way that we will develop the discount rate for capital budgeting later on in the course, it will be composed of two pieces. The rate will be first a risk-free component, which can be linked directly to a government bond, plus a risk premium that compensates investors for the fact that the project that we're examining has greater risk than a treasury bill or a treasury bond. Put those two things together and we get the cost of equity that's useful for discounting cash flows. Now, that said, let's go back to one of the very first examples that we went through in terms of capital budgeting. Now, if you recollect, it was a very trivial example where we had $100 at the end of year one and $100 at the end of year two. And the way that we valued this project was to find a set of zero coupon bonds that exactly replicated the payoffs of the project that I'm trying to value. And we found those bonds. And the prices that I quoted to you were $90 for the 1-year bond and $80 for the 2-year bond. So, in doing this, we can actually figure out what the interrelation is between the term structure of interest rates and the discounting of the cash flows. So in the example that I've given to you, the bond that has 1 year to maturity with a price of $90 has an interest rate that's associated with it being 11.1%. Now, the bond that has a price of 80 has an interest rate that's associated with it that's going to be more like 12%. Right? The total return of this bond over the 2 years is exactly 25%. So here's an example where the interest rate for 1 year and the interest rate for 2 years is different. When we constructed our example, we found these bonds, they replicated the cash flows, and we argued that the value of the project is exactly equal to the value of these bonds today. Notice that in doing this, we're using bonds that have different maturities and have different interest rates. So, when we're actually doing the project evaluation, we've got cash flows of multiple maturities. What we would do is to take the differences in the term structure into account. So if the interest rate for the first, the risk-free interest rate on a government bond for the first year was 8%, and for the second year 9%, the third year 12%, and the fourth year 15%, if that was the case, then we would allow the discount rate for different maturities of cash flows to differ. And remember, the way that we get the discount rate is to take the risk-free component, which is the government bond component, and add in the risky component. And as I mentioned earlier, this risky component will be determined by either the capital asset pricing model or the arbitrage pricing theory. So the lesson here is that it doesn't make any sense to ignore the information in the term structure of interest rates. If we're evaluating a 10-year project, it doesn't make sense to use the risk-free component as the 90-day Treasury bill. It doesn't make any sense to use as the risk-free component the 10-year Treasury bond. What we should do is to match the maturity of the cash flow with the maturity of the bond, year by year. And as a result, we get a sequence of discount rates that we use in our project evaluation. This, to me, is the most intuitive and the most economically sound way to do project evaluation, in that we use all of the information in the term structure, do not make the unrealistic assumption that interest rates of all maturities are exactly the same.